No. Okay, so yesterday we started talking about inverses of trig functions, right? And I made you repeat something over and over again, correct? To find an angle, we use the inverse. Let's say it again. To find the angle, we use the... Okay, now, did we start talking about this question yet? Kind of? Okay, so we're going to talk about the trig equation sine theta equals negative 1/3. We want to solve it on the interval from 0 to 360. That means we want to look at all 4 of our quadrants and find the answers. You okay there? I'm playing with your fingernails. Find the answers in each of the quadrants depending on where our answers might lie, okay? So, first thing we're going to do is we're going to determine the reference angle. We're going to determine the reference angle by taking the inverse of the value that it's equal to. Now, here's the catch. Remember our equation was sine theta equals negative 1/3. Am I taking the inverse of the negative? No. Okay, I need to always make sure that I take the inverse of the absolute value, always positive, okay? What that's going to do is it's going to give us that reference angle. We want the reference angle. The reference angle is going to allow us to find all of the solutions instead of just one that we would get if we put in the negative, okay? So you want to make sure that you always take the inverse of the positive value. Okay, so sine inverse of 1/3 is what we want to do. I'm going to insert a calculator page. And we're going to hit trig, sine inverse, and we're going to put in 1/3. And we get approximately 19.5. Okay? By the way, if you don't get 19.5, what's most likely the problem? What have you done wrong?
No, it's in the wrong thing.
It's in the wrong setting, right? You're probably in radians instead of in degrees. Okay, so you got to make sure that you're in degrees if you're not dealing with pi. Okay, 19.5 is what we get. So there's my reference angle. Are we okay with that? All right, now, in what quadrants is sine negative? Because remember, we're going back again. The original equation was sine theta equals negative 1/3. So I want to know where it's equal to a negative. So where is sine equal to a negative? Good, quadrants 3 and 4. Okay, quadrants 3 and 4. So, how do I find those two angles? If I know the reference angle is 19.5, how do I find the angles that exist in quadrants 3 and quadrants 4? Do you guys know the rules? What about quadrant 3? What do you think we need to do? Good. So quadrant 3, the rule is going to be, where's the Q? There it is. So quadrant 3, right? My rule is going to be 180 plus my reference angle, which in this case is 19.5. What do you get? My brain is not functioning correctly today, guys. Okay, quadrant 4, what do you think my rule is? Good. 360 minus 19.5. That would be second quadrant. Okay. So 340.5. All right. So what I've done is I found the two angles at which sine is equal to a negative 1/3. Those are my solutions. Remember, we always take our solutions, we put them in curly brackets. 199.5 degrees and 340.5 degrees. Okay. Degree symbol is in your question mark, exclamation point button. All right, so first thing we did is we took the inverse to find the angle. We took the inverse of what kind of value? We took the inverse of what? Was it positive or negative? The positive. Okay, you take the inverse of the positive. That gives you what? The reference angle. Once you have the reference angle, what do we determine? What quadrants? Great. So once we know the quadrants, then we can determine the actual angles. Are we okay? We're going to do a bunch more of these. Okay so far? Okay. All right, so here's our steps. Step 1, determine the reference angle using inverse sine or inverse cosine. Again, make sure it's the positive value. Step 2 is determine the quadrants in which the terminal ray of the solution lies. So if it's a negative, where is cosine negative? You're going to figure out your quadrants. Step 3 is to draw the rotation diagram. You don't necessarily need the rotation diagram as long as you know the rules for each quadrant. Okay, so let's real quick go through those. First quadrant is just itself, right? Second quadrant, all the way around, 180 minus. Third quadrant, 180 plus. Turn it on. Fourth quadrant, 360 minus. Okay, so those are your rules. They're different from the rules that you put on your paper plate, guys, okay? Those rules were to find the reference angle. Now we have the reference angle, we want to find the angle. Works in the opposite direction, okay? And then step 4 is to calculate the solutions to the equation, okay? The interval describes to you where you want your solutions. So if the interval says from 0 to 180, you're only looking for solutions in the first and second quadrant. If it says 0 to 360, you're looking for solutions from all the quadrants. Okay, are we ready? Talk to me. Yes, okay. You do have to speak to me. All right, so we're going to go through and solve each one of these. Okay, I'm going to pull up another page so it's easier to see. And we'll go one by one through these. Now, solve each of the following values for theta on the interval from 0 to 180. So what quadrants are we looking for solutions in? 1 and 2. Good. So are we at all concerned about third and fourth quadrants? Okay. So 10 cosine theta minus 1. Okay, guys, what's my first step? Add 1. Good. Remember, you have to isolate that trig function before you can take the inverse. Okay. So we're adding 1. Good. Divide by 10. Okay. What am I looking for? What am I looking for? The angle. What is the angle represented with or by? Here. Theta. Good. I'm looking to solve for theta. Theta is the angle. To find the angle, I use the inverse. Okay. So how do I write it? -1 of equals theta. Remember, this is the inverse, right? These two things switch places for me. X and Y switch places, right? Yep. Okay. So go ahead and find me cosine inverse of 1/10 in your calculator, please. Notice we didn't have to decide, we didn't have to take the absolute value because it was already positive. Okay, so we were good. To the nearest tenth, please. 84.3 degrees. Okay, good. 84.3 degrees. Excellent. All right. Now, let's talk quadrants. What was our interval? 0 to 180. Where's cosine positive? Do I care about the fourth quadrant? No, I'm not going to be concerned about those. I'm only on the interval from 0 to 180. So, do I have an angle? That was what the interval stated, yeah. Do I have an angle in the first quadrant? Yeah. Do I have to do anything else? No. How did I know that I wanted where cosine was positive? What was positive in the original equation? How do I know that I want where cosine is positive? This is really important. How do I know that I want cosine to be positive? What is cosine equal to when we first started doing this equation? And then what was it equal to? And then what was it equal to? So once you get to this step right here, when the cosine is isolated and it's equal to a value, this is what you need to be concerned about, okay? What is it equal to? 1/10. Is 1/10 positive or negative? That's how I determine whether or not I want it to be positive or negative. In this case, there's no negative sign here, right? So we want where it's positive. All right, so when you get that cosine, sine, tangent, whatever it may be, isolated, look at what it's equal to. Is it positive or negative? That's how you decide what your quadrants are going to be. Got it? Okay, you ready to try another one? Yes. All right, what's the next one, guys? Yeah? Thank you. Okay, first step. Good. Subtract 3. Second step. Good, divide by 6. What do you get? Because it's 3 divided by 6. 3 is smaller than 6. If it was 6 divided by 3, it would be 2. But it's 3 divided by 6. Two very different things, right? Okay. 3 divided by 6. 6 divided by 3. What is this one? 2. What is this one? 1/2. How does it reduce? Right? 3 goes into 6 how many times? 2. So it's 1/2. See the difference? Okay. All right, so now I have the trig function isolated, right? It's equal to a number. What do I have to check for? Where is sign negative? Excellent. Thank you, Cassandra. All right, so where is sign negative? What quadrants? Negative 3 and 4. We're not using those, right? What interval are we on? 0 to 180. So am I going to have any solutions on the interval we're looking at? No. So how do I write that there's not going to be any solutions? Empty brackets. Or this is what I do not want to see. You paying attention? I do not want to see this. It is not undefined. Okay, this is a big no-no, and I will take off points. Got it? Does not mean the same thing. That does not mean no solutions. If you want to write out no solutions, be my guest. Okay, but do not put undefined. Understood? Because on the interval from 0 to 180, this is the interval that it's asking us to solve on. Sign is going to be positive, so it's never going to equal to negative 1/2. Okay? Good. All right, guys, what's the next one? All right, so I want you to go ahead and try this one, and we'll talk about it in a minute. Okay, guys, step 1. Yeah, subtract radical 2. Move radical 2 to the other side. Step 2. Good. All right. Now, I've got my trig function equal to a number. What am I concerned with? Yeah, where it's negative, right? Where is cosine negative? Second and third. Am I concerned about the third? No, not on my interval, right? Okay, now what? Take the inverse of what? Radical 2/2. Now, you guys should be able to tell me off the top of your head when cosine is equal to radical 2/2. Yeah, 45. Okay, there's your reference angle, right? Quadrants that in. First, is that going to be one of our solutions? No. Okay? That's where it's equal to a positive radical 2. We want it in the second quadrant. How do we get it? What's the rule? 180 minus, good. And we get what? 135. You should get 45 when you put it into your calculator. Okay, how many times did I just get done telling you not to put in the inverse of a negative? I must have said it like a dozen times, right? Do not do that. The reason being is if we're on the interval from 0 to 360, you now only have one solution, you only get half the credit. That's not going to allow you to find two solutions. It's only going to let you find one. You have to put in the negative. You need the reference angle. Got it? Okay. Don't forget that, guys. Was that all the questions? Yeah. Okay. So I want you to go ahead and try this one. You're going to notice something happens. See if you can describe to me why we don't get any solutions for this equation. Okay, so when I solve this out, I wind up with sine theta equals 5 halves, right? What's 5 halves? 2.5, 2.5, right? All right, so why is it that when I put sine inverse of 5 halves into my calculator, I get this? Why? Some of you got non-real calculation, right? Why? Yeah, awesome. It's bigger than 1. What do cosine and sine, what two values do they oscillate between? Negative 1 and 1. They oscillate between negative 1 and 1. Does it ever get any bigger than 1? No. Does it ever get any smaller than negative 1? No. So is it ever going to exist at a value that's larger than 1 or smaller than negative 1? No. Okay? So when I got here, I could have automatically rejected and said no solution. Okay? Sine and cosine, notice I'm not saying tangent. Okay? Sine and cosine will never be equal to a number that's larger than 1 or smaller than negative 1. Tangent, on the other hand, is different because we know tangent's range goes from negative infinity to positive infinity. So that you can have larger solutions. Sine and cosine, you cannot. Okay? It does not exist outside of the range from negative 1 to 1. Okay, guys, so I want you to go ahead and try the first one. Now, I want you to notice the interval, 0 to 2 pi. So is that in degrees or radians? Radians. So how are you going to express your answers? In radians. Okay, so we're talking in terms of radians now. So real quick before you go on, we need to know our rules in our quadrants based on radians as well. Okay? We know that quadrant 1 is just going to be itself, right? That's our reference angle. Quadrant 2 we said was 180 minus. What is that going to be in terms of radians? Yes, you turned your brain on. Good. What is it? Very good. Pi minus. Okay. So what's it going to be in the third quadrant? Yeah, 180 plus or pi plus. And then 360 minus or 2 pi minus. Okay. So you're actually going to be using these, the pi, when we're finding the values, and I'll show you how to do that, okay? So we're going to actually do this first one together. All right, so the goal to start is to do what? Yes, isolate that cosine x, right? We want to get it by itself. How? Good, we're going to start by dividing both sides by 2. So we get cosine x plus 1 equals 1/2. Excellent. Subtract the 1. What's 1/2 minus 1, guys? Negative 1/2. Good. Great. Okay, now, before we go any further, we check and see what? Good. Equal to a negative. Where's cosine? Second and third. Awesome. Great job. Okay? It's equal to a negative 1/2, so we know it's going to be second and third. Now, are we going to take the inverse of the negative 1/2? No. Yes, you're going to find the reference angle. And how are you going to find the reference angle, Joe? Are you going to take the inverse of the negative? What are you going to take it of? The positive, and that's going to find you the, yeah, okay. So cosine inverse of a positive 1/2. And everybody off the top of their head should be able to tell me when cosine is equal to 1/2. 60. Awesome. What's 60 in radians? Pi over 3. You're kicking butt today. Okay, pi over 3. Awesome. All right, now, we know the reference angle. That's the reference angle, right? But we want it in what quadrants? 2 and 3. Now, here comes my rules, right? We said it was pi minus and pi plus. All right, pi minus and pi plus. There's our rules. So it's going to be pi minus pi over 3 and pi plus pi over 3. It's not nearly as difficult as it looks, okay? It's simply adding fractions. What do we have to have in order to add fractions? Common denominator, right. I don't know. None of you are going, right? So no worries. Okay, so what's my common denominator going to be? 3. Now, this is really easy, right? Really easy here. Common denominator is going to be 3. That means this has to be, and this has to be 3 over 3, right? Because if I were to go and cancel those out, what would I be left with? Pi. So it should be really quick. So if the denominator here was 4, this would be 4 pi over 4. And if this was 5, this would be 5 pi over 5. Okay, so you're just looking at the denominator and adjusting this first one. Got it? Okay, so what's 3 pi over 3 minus 1 pi over 3? 2 pi over 3. And what's this one going to be? 3 pi over 3, right? 3 pi over 3 plus 1 pi over 3. 4 pi over 3. So those are your answers. So that's not bad, right? Working in radians, it's not too bad. Just have to remember how to get that common denominator, which shouldn't be an issue. Just look at the denominator and put it in there. We okay? We're not done. We're not going anywhere. I have like 5 more minutes with you. I cherish every moment. Ready? Can I make it go away? Joe? Good? Okay. Oops.
We were in a speed chase last night. Oh my god, I was on my road. I thought
This is recording.
it doesn't matter. I said on my road. No, it's not on your road. Well, yeah, but we got my
Go ahead, guys. What's the interval? 0 to 2 pi. So your answers are going to be in terms of radians. Good. So go ahead and give it a shot. This should be really quick. All right. So you should have subtracted 3 and divided by 2, right? I'm going to stop right here. Why? This is not bigger than 1. It's not bigger than -1. It's smaller than -1. It's smaller than -1. Can cosine ever be smaller than -1? No. So, are there any solutions here? No. So there you go. Okay? All right, so your homework is pages 4 and 5 tonight. Please make sure that you do it. You should be able to do every single one of those problems. It's really not too much. And come in with any questions that you have tomorrow. Okay? Be on time. Make sure you're in. No, we're not having a snow day.